Welcome back. Let's see the student workbook problems. Okay, you are supposed to do. That's why student workbook problems. And while solving, if you face any issue, maybe you can look for the solutions what we are seeing now. Okay. Write down problem number 1 from student workbook. Assuming op amp is ideal, then the voltage gain of the amplifier shown below is. I hope you already did it. Okay, this is straightforward, but for the sake of completeness, this is what is 1. You can say, let us solve level 1 problems. Okay. Now, first problem. Assuming the op amp to be ideal, the voltage gain of the amplifier shown below is. Circuit is minus, plus, this is V0, R2, R3, R1, and this is VI. Okay, now what is V0 by VI? That is V0 by VI. Okay. Tell me, negative feedback or positive feedback, what is our procedure? You take any op amp problem, just find out whether it is negative feedback or positive feedback or open loop. Surely it is negative feedback. Output is sampled and then fed back at negative terminal. If op amp is in negative feedback, then what is the next step? We need to apply virtual current concept, or virtual current concept is valid. What is virtual current concept? This is 0, then this is also 0. No need to apply your brain, just apply nodal analysis, you'll get the answer. Okay, no need to say what is this and all. Okay, now if you apply nodal analysis, what you get? Tell me. 0 minus Vi divided by R1 plus 0 minus, what is this? V0, right? 0 minus V0 divided by R2. Current leaving from this node plus current leaving from this node plus current entering into op amp, that is 0, is equal to 0. Therefore, now tell me, if I take this right hand side, V0 by R2 is equal to minus Vi by R1. Therefore, what is V0 by Vi? V0 by Vi is equal to minus R2 divided by R1. This is nothing but your inverting amplifier. Maybe just to make it simple, can I write the same diagram? This is nothing but what? This is equally represented as, this is what your op amp, which is a negative feedback. R1, that is the input you are applying, and there is a feedback. This is what your V0, right? This is R2, this is R1, and this is your Vi, right? Can I say both are same? And this is what is connected to? This is nothing but your inverting amplifier. Then what is R3? Your R3 is nothing but load. Therefore, load is connected. This is what is our load. I can say R3. Therefore, now tell me, this is what is your amplifier. When I say this is what is your amplifier, this is what is your amplifier, right? With respect to input, this is what your output. Whatever may be the load, it has to give V0 with respect to Vi. And we know that this is what is our buffer amplifier, voltage amplifier. When I say voltage amplifier, the output impedance of your op amp, right, is equal to 0. When output impedance of op amp is equal to 0, then simply whatever output voltage that you are giving to load, it will not change, it should not change. Therefore, there is no loading effect. If there is no loading effect, your V0 will be applied directly to R3. It is independent of this. Therefore, indirectly whatever output you are getting, you are giving to load. It is not impacting the voltage gain of your amplifier. If op amp is not voltage amplifier, then whatever load you are connecting, there is a loading effect, then the gain of the amplifier will change. Okay, assuming that R3 is very much greater than the R0 of your op amp, which is 10 ohm, then if this is 1K, 2K, 3K load, definitely you can ignore the output impedance effect. Okay, what else may be? If you apply nodal analysis, you are going to get the answer, which is V0 by Vi is equal minus R2 by R1. Write the problem. Now problem number 2. Over. Now problem number 2. In the circuit shown below, what is the output voltage if a silicon transistor and ideal op amps are used? Okay. Right? Then asking for V0. What is V0? Option A minus 15, option B minus 0.7, option C plus 0.7, option D plus 15 volt. Okay. Okay. Therefore, this is what is our problem. Negative feedback or positive feedback? There is a transistor, right, which is connected between output to input. Therefore, if transistor is conducting, then there is a negative feedback. If transistor is not conducting, then open loop, right? Do you know the status of transistor? We don't know. Then it is nothing but PN junction diode. I told you, right? What it may be. If you want to know status of anything open, then you'll get to know. Therefore, this is nothing but NPN. Therefore, this is nothing but NPN transistor. If you open the transistor, therefore, open the transistor to find its status. To find, it is like diode, its status. Okay? When you open the transistor, minus, plus, now you will be getting what? This is what is our open terminals, right? This is what your V0 and this is 5 volt. This is 1 kilo ohm and this is what it is. Now this is plus 15 and minus 15. Okay? Even it is not connected but transistor is present. Okay? What does it mean? The transistor is present, it is not connected but transistor is present and it is connected to 0 volt. This is collector, this is emitter. It is not connected but it is present. Therefore, now tell me, this is nothing but an NPN transistor, this is N, this is P, this is N. Okay? Now, if you take a PN junction diode, this is what your BJT, right? This is what your PN junction diode. Your P is connected to 0, N is floating. Whatever voltage you get here, based on that I can say whether it is on or off, what else may be. Just listen. Tell me, if transistor is open, then this is nothing but open loop op amp. Therefore, now it became open loop op amp. No negative feedback. If there is no negative feedback, right, we cannot use virtual ground concept. Don't say this is 0 because now it is open. If this is not there, no feedback, it is simply comparator. When I say this is what your comparator, then compare the voltage between inverting and non-inverting terminals, then you can find what is your output. Okay? Tell me, what is the voltage? If there is no current which is what is flowing through this because it is floating, then the current entering into op amp is 0, then the drop across 1K is 0, then this 5 volt will come here. When this 5 volt is coming here, and what is this voltage? This is 0. Compare, because it's a comparator. Then tell me which is more. 5 is more, negative is more. What is your V0? Your V0 is equal to minus 15. The lowest power supply what you have from your op amp, that is what you will get it. Therefore, now tell me, if transistor is opened, then the transistor base is connected to 0 and the transistor emitter is connected to minus 15. Therefore, P is connected to 0, but don't think that it is off. I told you, right? We have to see other terminal. If the other terminal is having negative voltage, therefore now 0 minus 15, your PN junction diode can conduct. It needs only 0.7, but it is having more than 0.7. Therefore, whatever it needs, it will take. Remaining voltage will be given to some other circuitry. Or op amp will not give that much. But if you have open circuit a transistor, your output will be minus 15. Now bring back your transistor. Now connect transistor. When you connect transistor, it is seeing 15 volt across VBE. Yes, it will be on. It will be strongly on, let us say. Then what you get immediately, but how much it needs, it will take. Therefore, your transistor Q is having VBE greater than or equal to 0.7. Therefore, it will conduct. Therefore, your transistor will be on, then virtual ground concept is valid, right? Therefore, now if you calculate, your transistor is on. When transistor is on, this is minus, plus, this is 1 kilo ohm, this is 5 volt. Now your transistor is conducting. Conducting in the sense, let's see what is the region and what is the voltage and all. This is what your V0. Now this is ground. This is collector. This is emitter. This is base. Okay. Now tell me, it is conducting. Now when it is conducting, we know that it is conducting. Then there is a negative feedback. If there is a negative feedback, virtual ground concept is valid. Yes. Now this is what is 0 volt. Therefore, now transistor is conducting. Therefore, negative feedback. If negative feedback, then nodal analysis or virtual ground concept is valid. Virtual ground concept is valid. Then we are applying nodal analysis. If nodal analysis is applied, then tell me, just observe clearly. Now let's see KCL, then let's see KVL. Tell me, this is 0 because of virtual current concept. This is 5 volt. Can I say there is a current which is what is flowing through 1K? What is the current which is what is flowing through 1K? 5 minus 0 divided by 1K. What is 5 minus 0 by 1K? 5 by 1K, 5 milliampere. Therefore, 5 milliampere of current is flowing through 1K because of the voltage at this node 0. Tell me, therefore this 5 milliampere. Current entering into op amp 0. That 5 milliampere should flow through collector to emitter. Therefore that current will be taken by your op amp to satisfy KCL. According to virtual current concept, Ohm's law, 5 milliampere, KCL, current which is what is flowing through collector to emitter. Now that is what is flowing. To see the current which is collector to emitter, transistor is conducting. That's why negative feedback. Now that current is going here. Therefore, to have the conductivity, we know that we need only what? Therefore, VBE should be greater than or equal to 0.7. Therefore, tell me, base is at 0, then how much voltage you will get? Right? Therefore, to have transistor VBE greater than or equal to 0.7. Therefore, tell me what is VBE? VBE is equal to voltage at base minus voltage at emitter. Therefore, VBE is nothing but 0.7 is equal to voltage at base 0. What is voltage at emitter? That is nothing but V0. Therefore, what is V0? V0 is equal to minus 0.7. Therefore, the output voltage of your op amp will be minus 0.7. Then when this is what is minus 0.7, tell me, when this is minus 0.7, because I told you, right, transistor needs only 0.7, 0 minus 0.7, then VBE is equal to 0.7. That is what is enough to have the conductivity. When this is minus 0.7, collector voltage is 0, then what is your VCE? Your VCE is equal to 0.7. Is it greater than 0.2? Yes, it is greater than 0.2. Therefore, what is the region of the transistor? The region of the transistor is active region. Therefore, active region. Your BJT is in active region. Active region means current source. It is a current controlled current source. Your VB is constant, current is constant. Therefore, that current is 5 milliampere. The 5 milliampere of current is flowing, but it is entering into op amp is taking that current to satisfy KCL. Therefore, what is the answer? Your answer is minus 0.7. Answer is B. It is similar to PN junction diode problem. If you want to find the status of anything, open it, find the voltage across open terminals. Based on the open terminal voltage, you'll come to know the status. Once you know the status, then you follow, then you calculate real voltages what you see, then you will get the answer. Therefore, now this is conducting, because therefore Q is conducting. Conducting means it could be saturation or active region. Now after calculating real values, we got to know it is in active region. Done? Now write down problem number 3. The circuit shown below, implement a filter between the input current II and the output voltage V0. Assume that op amp is ideal, then the filter implemented is low pass filter, high pass filter, band stop filter. All 4 options. Problem number 3. Minus plus. This is having a current source, but this is what is the II. Having inductor. This is L1, R1. Okay. Now asking the relation between V0 to Vi. I told you already the technique to find the type of filter, not asking for cutoff frequency. If somebody is asking cutoff frequency, then we have to find the transfer function. But here asking only for type of filter. Then further the technique is, tell me, if omega is equal to 0, because this is what is your input current source. The current is having 0 frequency, infinity frequency. When omega is equal to 0, then DC, this is nothing but your DC. Therefore DC means this is DC current source. Tell me for DC your inductor acts as a short circuit. And what is your circuit? Your circuit is minus, plus, this is a DC current source, then this is a resistor, but we have short circuit because your inductor acts as a short circuit. Then tell me, negative feedback? Yes. Even though you have some current I DC, let us say DC current, then what is your V0 now? Because even though you are having R1, right, short circuit in parallel to R1, short circuit, negative feedback, virtual current concept is valid, this is 0, then this is 0. When this is 0, the same 0 is coming here. Therefore, what is V0? V0 is equal to 0 volt. Therefore, now your V0 is independent of your input current for low frequencies. Okay. Now, at very high frequency, let us say omega is very high, right, or infinity, let us say. When I say omega is infinity, for AC or infinite frequency, it will offer infinite reactance, omega into L. Then it is open. For AC, inductor acts as an open circuit. For high frequencies, therefore minus, plus, then this is what is, you can take your inductor as open circuit. This is open, right? This is your R1. Now this is what your current source, right? It is a current source having sine wave, what it may be. Now this is what your II, right? Then this is what your ground. Then tell me what is your V0? Now V0 is nothing but what? If you take the same current, KCL. What is KCL? Current entering into op amp is 0, current coming out of op amp is 0. This is the current which is what is going to ground. That current has to come from your op amp. Therefore, the current which is what is flowing through R1 is nothing but II only. And this is 0, negative feedback. Therefore, this is 0. Right? Therefore, what is your V0? Your V0 is equal to what? V0 or what is II? II is equal to current flowing through this is nothing but V0 minus 0, V0 minus 0 divided by R1. Therefore, what is V0? V0 is equal to the input current II into R1. Therefore, it is proportional. Therefore, your V0 is function of input current. Function of input current. If V0 is function of input current, it is passing. Therefore, your input is passed to output. Then if I combine these two, with respect to omega, what is your V naught? For zero frequency V naught is 0, then maybe you'll get like this. At high frequency you get V naught with respect to this. Therefore what is this? This is nothing but high pass filter. This is high pass filter. I hope everybody understood. Okay. Ultimately, at very high frequency, your V naught is function of your input. Means input is passing. If you change your input, your V naught will change. Therefore, your input is having track with respect to your output is having track with respect to input. Means input is passed to output. But here your output is 0 irrespective of your input at low frequencies. Therefore, low frequencies it is not doing. At high frequencies it is doing. Just 2 points are enough. Sometimes 3 points. Therefore, we can find the type of filter. Okay. After this, write down problem number 4. If that is over, I'll give you 30 seconds. Try to write in 30 seconds. That is DC, this is AC. For AC inductor acts as an open circuit. That to high frequencies. Over? Done. Fourth problem. Assuming op amp in the circuit shown in figure is ideal, then what is V naught? Circuit is minus, plus, okay. Asking for V naught. You have 4 options. That is fine. Now tell me, negative feedback or positive feedback? Simple. This is op amp problem. Negative feedback or positive feedback? Negative feedback. Right? It is at inverting terminal. Therefore, nodal analysis. Sorry, virtual ground concept? Yes. Then what is the voltage at this point? V2. Then what is the voltage at this point? V2. Because it is a negative feedback, we can use virtual ground concept. Then apply nodal analysis, you will get the answer. Very simple, very blind technique. Once you know that op amp is a negative feedback, then op amp is ideal, use virtual ground concept, then apply nodal analysis, you will get the answer. Then tell me, current flowing from this node, V2 minus V1 divided by R plus V2 minus current leaving from this node, V2 minus or current leaving from this node, V2 minus 0 divided by 2R plus V2 minus V naught divided by 3R plus current entering into op amp, that is 0, is equal to 0, right? Then R will be cancelled. Multiply with 6. When you multiply with 6, you will get 6V2 minus 6V1 plus 6 means 3V2 plus 2V2 is equal to 2V2, 2V0. Therefore, what is this value? 6V2, 3V2, 9V2 minus 4V1 is equal to 2V0. Therefore, what is V0? V0 is equal to 9 by 2V2 minus 2V1. This is what your output voltage. Just mathematics. Once you know that it is nodal analysis problem, by applying nodal analysis, we got it. That too only one equation. If you apply nodal analysis at that equation, we get the answer. Something is wrong. Why? I just took it as V1. Because I am not finding this in any options. Fortunately, it found. For example, if this is what is found, then we will take it, right? Be careful. That's why. Don't do any silly mistake. What I did now. 6V2, 3V2, 2V2. Therefore, 9 plus 2, 11V2 minus 6V1 is equal to 2V0. V0 is equal to 11 by 2V2 minus 3 into V1. Is that found? 11 by 2V2 minus 3V1. Yes, answer is D. Answer is D. After this, problem number 5. Okay. Now, problem number 5. If the input to ideal comparator shown in figure is a sinusoidal signal of 8 volt peak to peak without any DC component, then the output comparator has a duty cycle of, okay, circuit is, this is what is the comparator, op amp in open loop, that is comparator, okay, minus, plus, and the reference is 2 volt, therefore now Vref is equal to 2 volt, and this is what is our input sine wave, right? That is what is our input, and this is output. This is output, and this is input, right? This is what is given. Now asking that 8 volt peak to peak sine wave is given, then asking for your duty cycle, output duty cycle. Therefore, what is duty cycle? DC means not DC component, duty cycle, okay? No confusion. Therefore, what is your input here? Your input is 8 volt peak to peak. What do you mean by 8 volt peak to peak? This is what is 4 volt, 0 volt, because no DC component, that's what he told, and this is minus 4 volt. Therefore, this is what is your input. This is what is given. Then asking for what is your output? Then what is output? Duty cycle, okay? Now, tell me, if this is what is given, what is your reference? Your reference is 2 volt. Therefore, this is what is your reference, right? What does it mean? It is a comparator. It will compare with the 2, right? If your input is less than 2, output is 1. If input is more than 2, your output will be 0. That is what. Therefore, let's plot output. Just listen here. What is your output? Your output is, let us say this is what your input, one cycle is enough. Okay, this is what is continuously happening, time t. Therefore now we are trying to find output, right? Output. Now the peak value is 4 volt, then average is 0, and then minus peak value is minus 4 volt, and then reference is, this is what is the reference, V reference is equal to 2 volt. V reference is equal to 2 volt. Okay. Now what is your output? Okay. Now let's see. This is 2, plus is 2. If input is less than 2, if it is input is less than 2, if input is less than 2 volt, then which is more? This is more. Then your output will be 1. If input is more than 2, then minus is more. You will get 0. 0 means opposite. What it may be. I am treating like logic 1 and then logic 0. Therefore, when input is less than 2, your output is 1. Output is 1. Therefore, your output is 1. Let us say this is what your logic 1. And when input is greater than 2, output is 0. Let us say this is what is 0. Some logic way I am just taking. Then again, when input is less than 2, your output is 1. When input is less than 2, output is 1. For less than 2, your output is 1. If you continue, maybe if I go for, or if I take one more sine wave, right, then what you get, this is what your reference, 2 is our reference, till that point, because this is less than 2, till that point it is 1, then once it is crossing, and it will be 0. This is what is the 1. Okay. Then what is your duty cycle here? Therefore, if you take it as the reference from here to here, therefore now this is nothing but your on time. This is nothing but your on time, T on, and this is nothing but your off time. This is your T off, right? On time. Therefore, what is your duty cycle? Your duty cycle. This is logic 1 and this is logic 0. This is logic 0 and this is logic 1. Right? Therefore, what is duty cycle definition? According to duty cycle definition, duty cycle is your on time divided by total time. Total time is nothing but T on plus T off. Right? Take it. Then we will see what is the duty cycle. Right? Now, if you know the crossover time, this time, problem is over. Right? Or we know complete period. If you take complete cycle, if you take radians, what is your complete cycle? 2 pi. Your sine wave will have complete cycle of 2 pi. Out of 2 pi, if you know this time or this time, we can find other time. Right? That is easy. Therefore, now tell me what is your total? This is nothing but what? Your T on by total period T, or out of total period T minus your off time. That is nothing but your on time. That is also fine. Divided by T. Anything is fine. Which is 1 minus T off by T. Okay, that's fine. Just listen. Therefore, let me apply mathematics. Therefore, what is your input? Let me say Vi. Therefore, according to mathematics, it is a sine wave having peak to peak of 8. Therefore, what is that? 4 sine omega t. Therefore, now if you ask me, this is what is our total period t is equal to 2 pi. I'm just representing in radians. Therefore, your sine wave is having completely 2 pi. Therefore, when you say this is 0, therefore this is 0, this is 0, this is pi, and this is what is 2 pi. Right? Now, if you know this time, the angle at which your sine wave will have 2 volt. What is 2 volt? Exactly half of your peak value, Vm by 2. Right? Therefore, for what angle you will get sine omega t should be exactly half. Therefore, because it is 4, that is what is the maximum value, which is nothing but Vm. Therefore, for what angle you will get half of the sine wave. Half of the 4 volt is 2. Therefore, we know that this is what is your theta, right? This is what is your omega t, but this is what is your theta, right? We know that sine omega t is equal to half, or sine theta is half at theta is equal to what? 30 degrees. What do you mean by 30 degrees? Sine 30, 1 by 2, or 30 is nothing but what? Pi divided by what? 6. 180 by 6 is 30. Right? Therefore, what is that angle? Then, therefore, at theta is equal to, pi by 6, what is your Vi? Your Vi is equal to 4 into sine pi by 6, which is 2 volt. Therefore, at theta is equal to pi by 6, your Vi is 2. Therefore, this is what is 2. Therefore, what is this value? This is nothing but pi by 6. Then what is the other point? It is also 30. Therefore, 180 minus 30, you will get 5 pi by 6. 5 pi by 6. This is pi by 6 and this is 5 pi by 6. And this is what is our 0, and this is pi, this is 2 pi. Right? Because other angle, sine 180 minus theta, sine theta. Therefore, sine 180 minus theta, how much theta you have? The same theta will be decreased here. Therefore, now that is what is 5 pi by 6. Now, you know what is off time. Therefore, what is your off time? Therefore, your off time T off is equal to 5 pi by 6 minus pi by 6. Therefore, out of 5 pi by 6, it will become 4 pi by 6. 5 pi by 6 minus pi by 6, 4 pi by 6, which is 2 by 3 pi. This is what is our off time. Then tell me, what is our duty cycle? Therefore, duty cycle is nothing but on time. What is on time? T minus 2 pi. Therefore, what is T? 2 pi. 2 pi minus, or I can say directly you can write, which is nothing but 1 minus, what is off time? 2 by 3 pi divided by 2 pi. Therefore, what is this? Pi will be cancelled, 2 will be cancelled, you will be getting, therefore, pi will be cancelled, you will be getting 1 by 3. 1 minus 1 by 3, you will get 2 by 3. This is what is our duty cycle. Therefore, if you ask me percentage duty cycle is 2 by 3, it will be around 66.7%. It is close to 66, means out of total period, 66.7% of total period is nothing but your on period. Okay, take it. think almost session is over. Okay, you can take it. We will continue in the next session. Okay, we will continue for level 1 student workbook problems. Right, we will look into problem number 6. Okay, thank you.